speaker has nearly 30 years of database and data integration experience. He's the Director of Technical Services at Attunity. Please welcome Richard Thomas.
Thank you all for coming out. If this gets a little too loud, let me know. A little bit. I welcome you all. We got obviously beverage students, help yourself. I want to keep it informal, interrupt, ask questions. We're going to talk about, and it's we got big data. To me, it can have many concepts, many principles. I'm going to hone in on a particular area. It's to me, when I think about it, not to related per se, but when I think about big data, at least as it's used today, it reminds me back when web services and all that concept was coming out, and how everyone was using the term and what it's going to mean. So today, big data can mean just about anything, depending on the audience and the circumstances. I'm going to take a look at it and the experience that I have, and a little bit more about myself. As like I said, I've been at this for a while, and I kind of evolved. Let's try this. Does that work?
Yeah.
Perfect. Okay, let's see if that works better. Hopefully it holds still. Look that way. I gotta hold my head still. So, as Eric said, I've been at this for a while. I kind of started in code generation, data access, and over the years as I've evolved, actually most of my career with Attunity, it's been data migration, data integration, working with legacy systems. I've dabbled around with the old digital computers, the tandem computers. They're still prevalent out there. People don't realize how many, literally tens of thousands of installs that are going today. We do a lot of work with, it's now known by HP Nonstop. Wall Street runs on that today still. I mean, it's very prevalent. What it brought us into was, getting into data and dealing with it in many different facets. Today, what we're certainly seeing is the sheer volumes of data at every level, whether it's database level, and in fact, when we're going through the questions, and Eric talked about what's the largest database out there, just starts to go. I actually would have guessed a lot larger, because we start hearing about the data volumes that are being generated by companies, organizations. A lot of it's unstructured, it's kind of just gangly, huge, it's out there. But even in the usable data that we can still query against work in, the volumes are tremendous. And I want to look at some options and way of dealing with that. So when we talk about big data, one of the first things that we're going to start running across is, you're going to get into the bottlenecks. What might have worked 5 years ago or 10 years ago is not probably a valid approach to handling all the data that your organization might have. So I want to talk about the impact of that. We're going to take a look about some of the best practices and how we can handle it. And there are lots of options out there, whether you're homegrown, you look at products. One of the things you want to start talking about, kind of the key resonating point, is the deltas. I can't think about all my data, but what's relevant to me is can I identify what's changing in my organization and act on it. And we're going to explore ways about getting to that. All right, so we're going to talk about the bottleneck. So what I'm trying to say here is we've got unbelievable different types of data sources. We focused a lot, and I know this group many times really hones in on database, but there's many other things, files, everything from web log files to all of the tweets, various other information that's coming out there. What am I going to do with all these different files that are popping up in my organization, along with all the more structured data? I'm going to work with it. Evidently, everybody wants access to it. We've got all these traditional ways of approaching it, but it's all irrelevant if we can't make it timely and deal with the staggering volumes that we're working with today. So when we start thinking about that, we've got the data, we've got the folks who want it and they're demanding it, is really how we're going to get there. And kind of the crux of what I'm talking about is we've all sat down and worked the data. We've had to, someone calls up from one department and says, can you write me a report? It gets in a particular data. And over the years, we were able to, as IT professionals, to cope with that. Now the problem is we probably want it from many different places, and the volumes, we start talking about terabytes, petabytes of data, it becomes unmanageable. It almost becomes hard to grasp what that means and how big it is. And you just can't go out there and keep grabbing it. So we got to take a different approach to how we're going to handle all of that data. How we're going to break up that bottleneck. So I'd like to believe that for many of you, these are common themes that you're going to be talking about. I want to think about it, the idea of almost like painting the Golden Gate. If you are moving the data at a rate that's slower than you're generating it, how are you ever going to get to the end of it? You will never be able to analyze it and get a grasp of what's going on in your organization. Obviously, these volumes are exploding the cost, and we still got to store it, we got to transfer it, we got to get it over our network, we got to use it. Given the diversity of what's going on and not what people witness firsthand and you've seen many times happen, we got to have multiple data centers. We're putting vast distances between the data centers because of the events that can occur. They can be so devastating to organizations. That costs even more. Getting the expertise and the ability to do it. You get a lot of data, you need a lot of people to work with it. And I think that a 4 and 5 kind of hone in on there is that it's got to be relevant. And relevant now can be literally seconds from the time it occurs. And because of the volumes, what in the world are you going to do with that? So again, we're talking about the challenges, the size, the number, the variety. It's not going to cease. It's only going to become more prevalent. There's going to be many different types of forms of data. You can't walk into any organization where they have one common relational database. Every organization I walk in today, there's at least 3 or 4 different flavors of relations. They kind of hit the whole spectrum, whether it happens as a result of packaged applications or homegrown events, or the idea that you've got some department who says, I got a great idea, and I'm just going to pull up a quick MySQL database or SQL Server database and start doing it. And then within years, this thing takes on a life of its own, and it becomes critical to what's going on in the organization. What do you do? How do you handle that? What's going to happen? So it's all over the place. I touched upon the idea of unstructured. The rate of unstructured data growth is unprecedented, and it's endless. And we all see it. We're exposed to it every day. We start thinking about things like Facebook and Twitter. As an individual, it may not matter, but it's becoming critical to organizations. A derogatory mark or something somewhat negative that's out there, you got to act on it. You got to work at it. You got to do something immediate with it. Just getting out your websites and all the places that you have to get it to, managing all the files that would represent is daunting. Because you just can't have one common website for any large organization. You go to Amazon.com, where you're really talking about literally potentially thousands of Amazon.coms that represent that all across the world to be able to maintain it. How do you manage that? How do you keep that common theme? And I want to kind of touch a little bit on the idea of being relevant. Zero latency. And what we may have done as little as 5 or 10 years ago won't work today. So what is the approach? What are we going to deal with that? How are we going to get away? What's a better way to look at the data? How are we going to approach it? To approach the cost, so we got to come up with something that gets us out of voice coding everything, writing scripts, writing programs. The first original way of getting data from A to B was literally a COBOL program. That's really when we started seeing real traction, developing and building it. At one point, we had 80-90% of all the data on an IBM mainframe. If you needed to change it or work it in a different way, some guy 20, 30 years ago wrote a COBOL program. The irony is it's still going on today. There's still a significant amount of data in kind of file systems and in databases and how you can work with it. So start talking about ease of use. Can we get out of always having to drop and write code? There's a place and a time for it all the time, but we got to evolve. We got to move on. Focus on analyzing the data and working with it, not the mundane task of transporting it, moving it, and getting it when it's relevant. And obviously, given the volumes, you better start thinking about coding with it. And I'll start throwing out some numbers of things that I've been exposed to in the day-to-day dealings of what I do. At any one time, I might be dealing with 10 or 20 different integration projects, really kind of this we talked about in one of the questions, this idea of change data capture. A different way of going after the data that you understand, but get the relevant stuff to work with it, and what change data capture brings is this idea of real time. We'll kind of explore what that means. So use cases, this list just keeps going on. And and there's no doubt that everyone in this audience is doing some of this. They've got many different heterogeneous data sources, multiple relational databases, some file systems that are still out there. Spreadsheets can still be a critical factor of what you're doing. With all social media, you've got all these little files, and the presence of your website, what that means from everything from web blogs to the social media feeds. How you deal with it, how you bring it all together, how you making sense of that information. And as I said, it's got to be in that real-time basis. You can't find out a month, a week, or a day later that you launch something out there and it's not well received, people are struggling with it, they're not beginning to get their heads around it. You've got to know almost immediately to build that. So time is significant. And what we want to do to be able to use it in all these different types of technologies that are proliferating in the organization. Now I'm going to kind of, almost like a funnel in the way I want to approach the presentation as we keep honing down on an area that I want to talk about. So ETL, which is the extract, transform, and load. There's actually products out there. There's a whole product categorization. Many of you have an enterprise class ETL tool. Anyone who happens to work in the SQL Server environment, or at least as a SQL Server developer, actually is in possession of an enterprise class ETL tool. Today it's known as SSIS. And it's stepping up the mark of being able to achieve that. You start playing around with that. This is essentially an ETL tool is a graphical environment to start pointing at a source and start thinking about taking that data and literally writing potentially incredibly complex applications and logic and putting it someplace. Typically, what we start thinking about is like a data warehouse. I want to get my data and get it into the data warehouse. This is traditionally what we wanted to do. And it could be, the idea is I've got a graphic tool environment, I can get rid of all of the programmers. And as we know that everything that they try to project that programmers will be irrelevant has been turned upside down. In fact, the more innovative we get in our solutions, the more we can get at the information, the need to get more people to get at the information. So the days when one COBOL programmer might have satisfied this methodology, and COBOL was in fact the first productized ETL tools. It actually generated COBOL code. It actually started coming out of the IBM mainframe, and that's where it started. And then some innovative companies got out there and created a lot of products, and when it became mainstream, the Oracles, the IBMs, and then, one kind of an outline there, Informatica now is actually a $1 billion company. A huge industry grew out of this. And then all these bolt-ons, we started getting into the idea of data cleansing and profiling and working all this. So it just fueled the technology. With the success of the data warehouse, you start getting all the analytics and all the business intelligence tools. So a whole reporting industry comes out of this. So we just keep building and building our technology stack, and we need to work with the information. And in this huge explosion of all this information, what are we going to do? So we got our sources. In this data, when I got into this, the baby file systems were clearly it was settling itself on relational databases. They're still the dominant place where data is. It's a critical part of the organization, but it's moving beyond that. But what essentially we do is we find methods of getting at this, and we always think about, every night I'm going to go out there, I've got a window of opportunity, and to keep it simple, I'm just going to take everything from A and put it into B. It may be coming from many different sources, but I have the horsepower in the network to do it. That's not true. You can't do that. You cannot bulk or batch load your way to a solution, not the least of which you need that quiet moment, that opportunity to get it done. Those windows have shrunk. Maybe you had a 6-hour window each night. I have yet to find an organization that has a 6-hour window at any time. Not the way they run today. They're around the clock. So it's daunting. When we start looking at alternatives to that, we still are kind of held back in that kind of coding command line mentality. What can we do to go beyond that? What can we do to change it? So I guess it kind of is the point when I started getting into this whole data integration piece. One of the key things I did is I worked for one of the projects we worked on was a major weather provider. And there literally was a time that a 4-hour latency was utterly and completely acceptable. And if we had witnessed enough to know that, people really want it within seconds of what's really going on. We're all got the app on our phone and we're literally looking at the Doppler, trying to figure out what exactly street I'm going to go down and try to avoid it. So it's got to be instantaneous. So in the short span of where I've done this, halfway through my career, I get involved in this, and we really just had to provide that real-time data access to the existing data. Now that we find even that's not sufficient, not only all on real-time for what I got, but I need to move it around on a real-time basis. And so it keeps evolving. So when we talk about this, there are many ways, whether it's homegrown, handwritten code, new code. I got my Java C# that's doing this. I'm running an application or tool that achieves me, but I've got to get the information out. I've got to go into my existing data systems. I've got to understand them pretty well and keep writing extractions to get the information out. I've got to work on it. I've got to have the opportunities to run it, and it would work when we were talking about megabytes of data, maybe gigabytes of data. But now when we start talking about terabytes of data, it's not feasible. You can't keep moving it all around, even though you need it in many different locations. So the next thing that we start talking about is we're finding that the need to do complex transformation. And the idea is I'm going to use logic to change the way the data looks, consolidate it to make it more usable and workable is valid, but if I want to evolve on that, and the way we put it in the data warehouses, so to the traditional data warehouse would probably be the same dominant relational database that's in your organization. Why not? You got DBAs who know it, they're good with it. I really just need to see the data in a different way. And so I just start dropping my data into my Oracle, my SQL Server, my SQL, and do all that. But as the organizations grow, we have to start thinking differently about the data warehouse. The data warehouse literally now becomes an appliance. It goes beyond just the database. We've got to tune the network, the hardware, the cards, the database. So we start talking things like, Teradata, Netezza, PW, that, Microsoft is an Oracle, Exadata. It's literally, we tune every aspect of what we're doing, and then the database warehouse takes on a whole new meaning. It is literally an entire technology stack to be able to manage this volume and cope with it. So now we got this huge ability to receive this information. How are we going to work with it? So back to that idea of the bottleneck. So bulk loading all of the data, as what we traditionally do, was the first obvious bottleneck into it. Between the volumes and the variety and the method that we were using, grab it all as soon as you can, as often as you want, it comes back to that one guy painting the whole cake. He's literally never going to get around to it in time that I'm moving my data at a rate that's slower than I'm generating. So what we want to talk about is it's subtle. It's a change of words here. When we talk about the idea that I'm going to put it someplace, I still want to extract it, but we want to talk about a different way of doing it. What we find on any given day, only a small percentage of the data changes. So if I've established my data warehouse, I've got it into my appliance. If 1, 2, maybe 5% of the data is changing, I just want to recognize that part. Just point out to me what changed. If you can point out to me that it changed right now, and then I can just get it in the warehouse, that means that any time I run whether I'm powering a dashboard, a learning system, anything like that, I know that we're looking at a sub-second difference between what I'm warehousing it into versus what it occurred. And to do that, if we work at just what changes, we stand a chance of achieving that. That we can accomplish that with today's technology and get just what's relevant to us. To take a step back, as developers, we've approached this. Let's talk about some of the ways to do it. If we were all just born brilliant from day one, that we knew where the organization was going to go, and we laid out a perfect database architecture. We had enough sense to put timestamps on every one of our tables, unique primary indexes on everything, that we have the perfect database that anytime we want to look into it, the database will tell us what's new. Or, as an application architect or developer, I wrote all my data into a database, but I had enough sense to drop breadcrumbs every time I did it, an audit trail or something. So I always had a way, either through the app or the database, to know that it happened. Well then, what happens if there's new apps written or different databases? So then we start thinking about the idea of a trigger in the database. Or every time something comes in there, I can pop a trigger and I can let somebody know that something new happened. There's many different ways in which we can get at it. Battles have been fought up and down the industry on what's the right way. Universal database, universal data access, triggers, my app. How am I going to know when something in my organization's changed and how am I going to get at it? Pretty much what you're going to find, the battle's been settled out, that it's log-based. And this is the idea that the most significant databases today have in their own ways log files. This may not be the way we traditionally wanted to use them, but they give us insight to what's going on. We can look in there, find out what's changing, find out what's been committed, and identify just what we want. We can get a glimpse into that delta of what's changing. We have the database of the logs. Real time it's out there. There's some things out there that don't have logs. Then figure out a way to get on it. There's literally some of the first ways they did it. Some people came in with the idea, well, we'll just throw an intercept in between everything we do in the operating system. It can work. It's a little scary when you take out version 1. Learn that the hard way. You kind of like whole CPU, but it's one way of doing it. But what we have found traditionally safe is that we can establish log-based, work at that, identify what's going on in the changes, and get that out. It's going to be real time, around the clock. There's no idea, concept of batch windows, holidays, weekends. We're just getting it. We're pulling everything out of the source database. We're identifying it. And even the classic ETL could have worked in this methodology. You can still look at that idea. You can still use ETL to do it. But what we're starting to find out, I'm going to go back to that, the appliance, the analysis. And you've got to crunch the data in such a way. What we're really finding out is we get all the information, let's just put it where we really think we're going to want it. And every one of these incredibly scalable big data engines are coming with their own suite of analysis and they're meaning get it where we want it and let this machine in memory, on platform, in device, crunch the data. So now all of a sudden we deal with the tremendous volumes, what's going on, we can establish the ability to do this. So it's subtle, but we've kind of changed it around, kind of flipped it on its head. I say extract. I don't like to use the word extract, but it's what's known in the industry. What I really want to say is I want to do change and capture. I want to identify the deltas and replicate it just like that. So the advantages of doing this. Obviously, you can start introducing different types of data warehouses, what we want to work with, constantly kept up to date. You're receiving the data in a real-time basis, so it's just moving over as it changes. The latency is critical now to these organizations. You've got to be able to act now. Act immediately, act on what's relevant, and be able to put it to use. They're saying in here, talking about 5 to 15% of data changes. I don't think it's that high. I think it's probably more like 1 to 5%. I think the data volumes, because from all data sources, can grow at that rate. But we need to just get the deltas, identify the changes, what's going on there, get it, put it over. So traditional ETL environments can be significantly expensive. Kind of one of the things I like to talk about, it's actually friends and family always talk about. Close friend of our family send their daughter off to a beautiful university. She couldn't wait to call up mom and say, Mom, laundry machines are free. Mom said after writing a $45,000 check. No, honey, they're really not free. There are instances where they'll quote say, I'm just going to throw in an ETL tool for you. But some organizations do that. It means you've got to buy a different level of database that might be 5 times the cost of the traditional data. So there's never really free. There's never free. There's always a catch. There's always something hanging around that. What does that mean? So what we look at today, either you've got a lot of manpower, and that's the cost of doing it because you're doing traditional ways of doing it, or you're bringing in enterprise class development tools, ETL tools, that are exceedingly expensive. You get. I talked about if anyone who wanted to look at one, go get SSIS developers. You care to take that to production, the standard pricing method says it's 5 times more. So it's free. When you get 5 times more for the database. What other ways can we attack this? What other ways can we look at getting at the data, stay relevant, move it quickly, and start moving down the tremendous cost? Yes?
Can you expand on the second point, reduce latency to data warehouse?
Which bullet?
The second bullet, reduce latency to data warehouse. What do you mean by that?
Yes. All right. So if we go back, what I mean by latency, if the most classic way to say it is I run a batch-based, and once a night I get a 2-hour window, and I move the data that I want from source to the data warehouse. So we have a 24-hour potential latency on the relevancy of the data. What I'm going to show is that if we put the right technology in, that you're actually sitting there on the source databases, right here. We come in with the technology, for me, it's really an agent. I have an agent that's sitting there sniffing the log file. And you've gone in and told me, I want to know when anything moves on these tables and databases. If something happens, I want to know. I want to know this table, this column, this field, tell me when it happens. And the minute that happens, it's recognized, depending on the source, the target, the infrastructure, it can appear over there within a second of being changed. And that's what I mean by latency. It's not getting there a week, a month, a day, an hour. It's getting there, it changes that it's happening in your operational data store, and you go off in your analytical engine and it's there.
No, but are you loading it into the data warehouse direct? Is my question. So you, as per you, if I'm getting it right, correct me if I'm wrong here, you are saying you are loading the data directly into the data warehouse like
Yes.
OLTP, instantaneous.
Yes.
Without any normalization, without any transformation.
It depends. It depends on, so there's an excellent question. What the gentleman asked was, all right, in an ideal world, how relevant am I going to be able to do this? And what happens if again, if these are traditionally relationals, the amount of changes to data warehouse can be minimal. And I'll get more into what if I do need to transfer them, how much can I do? I'm not saying that ETL would go away. But what we started seeing is somewhere between 50 and 70% of what does get moved can go as is. Because you have multiple data warehouses, take it from there. The apps are becoming more standardized. So I'm running SAP and I've identified 300 tables that are relevant to sales data. That can, in almost most part, head on over. And then the subtlety of this is, let's go ahead and take it real time. Let's drop it into either a temp table or the methodology that's doing it, and let the analytic engine, if it needs to normalize it or break it out or put it into different tables, accomplish that. So, great question. There are going to be cases when the complexity of this data is so ugly that even an off-the-shelf ETL tool won't work. I got a guy on my team who has done amazing things with ETL tools. And I remember when it got the ugliest, when it was going from one affinity type program to another, that at the end of the day, when he had to transform some of the most ugliest parts of it, he wrote code. Old COBOL program, now he wrote C#. And he wrote code. And that won't go away. There'll be points when you've got to write code because the complexity of what's here and what you need to achieve here. But if you start listening to the guys who are pushing the big engines, meaning your Teradata, your Exadata, your PDW, one of the questions about Vertica. It's a columnar-based, high-scale engine. What they're asking you to do is minimize what you can, get it so it makes some sense, get it into the engine, and then use the tools that they've got in there. The hard part is getting it into Teradata, getting it into PDW, getting it into Vertica in a timely manner that then they can act on it with the analytics and the tools that they've got to do that. Did I answer your question about latency? The latency and reducing the amount of the key pieces. These are the key takeaways. Obviously, cost and everything else is going to be very relevant to what we're going to do, but this bullets 2 or 3, that's what it's about. You know, what am I going to do with technology? So when you start optimizing, when you do this, obviously if I'm moving less data, I'm beating my network a whole lot less. And the networks are going at unprecedented rates. We ourselves start talking about if you're using a high-speed data appliance, we recommend 2 10 gigabyte network cards. And these high appliances are designed to take it that way. So you've got huge bandwidth to push this stuff through. And if we can get it, so we're just moving those deltas, it's very viable. You can maintain that real-time basis. When we start looking about that resiliency, outages, we're going to have them, we're going to deal with it. If you have an outage on your network at the time when you were supposed to do the bulk move, then you may be a whole day or a week away when you get a chance to do it again. work with the right technology, get the kind of bandwidth where you have, it's built into it. The idea if I'm going to be working in kind of a CPC methodology between my sources and my data warehouse, I want to have built in there the resiliency that they're good. It's not if, it's when am I going to have database offline, data warehouse, network, it's going to happen. So what am I going to do to be able to catch up? How am I going to handle that? Back to the idea of the logs, maintaining it, and maybe in transit, kind of stay onto it, or be able to work with that idea of being able to get the data, get it securely over there, and be relevant. So, what I want to start talking about then is the ideas about, if we're going to do this, I want to replicate the concept of change data capture. I want to be able to efficiently manage and move all of the files. Basically, think the idea of manually copying files to the network, where you drag and drop, where you FTP them. Can I look at better methodologies for accomplishing that? More secure, more easier to use, literally hundreds, if not thousands of different websites and all of the files that make it up. What can I do to move it around? So we start talking about any data, anytime, anywhere. So
can I ask you what you mean by real-time data? I mean, if you're taking all this data and moving it into a data warehouse, I mean, that doesn't sound like real-time. I mean, it takes time for you to move that data in and consolidate it.
it can.
And aggregate it.
So, is it, and there's many different, so first off, to Jeremy's question, you asked more about real time. What do we mean about real time, and what we're talking about that? So if we worked in the idea of monthly, weekly, hourly, what can we do to improve on that? One of the key things we do is it has to actually, almost, when we think about it, it's committed. So literally a transaction happens in an operational-based system. It's committed. How long would it take for those changes to end up in, say, my data appliance? If it's fairly, reasonable types of transformations, reasonable types of logics behind it, and I don't necessarily need to invoke a program on the data warehouse, and we're seeing somewhere between 50 to 70% of the data is in a pretty good data model that I can work off of if I can just get it there. And under those circumstances, I think it's reasonable to expect that you can see, and again, volumes mean everything about the level of latency in your hardware available. But we're going into environments where we're looking at anywhere from 5 to 250 gigabytes of changes an hour. And remember, that's that 1 to 3 to 5% of data, so you can only imagine what ultimately is out there. And we're constantly, this is the number one thing that we're getting beat up on is, they don't call it, they won't say we mean real time, is they'll say the rates. We literally have, when we do it, we actually are broadcast. This is the latency. This is how much time between the source and the target is in there. It can be seconds, it can be minutes, it can be hours. And the relevance of it is it's possible to get it down to second per second. It is possible. Moving gigabytes of data that I'm only seeing from source into a target data warehouse within seconds. And that's what we mean by real time. It's not change here, change there. We might see that in kind of a DR environment. And that's another whole genre that we spend another half a night talking about. I want to talk more about the data warehouse area, but almost at the same concept of DR principles, that as it's changing in my online systems, I can realistically expect that I may be only a second, maybe a minute behind what's actually happening out in the field. And that's what I mean by real time.
How did you track of the offset, what is being changed? And I'm going to read them like events or something.
So how do we keep track of what's changing?
Yeah, what is changed? What is the offset?
So the way we track the changes, and again, I'll go back and we'll talk because I want to stress the importance of this. And when I talk about, for the last 30, 40 years, there's many ways of doing it. Everything from the developer to put something in his code to kind of drop out like an audit trail and say, this is what's changed. So triggers on your database. There's lots of ways of doing it. What we found that's relevant today is we say non-invasive. You don't have to change your applications. You don't have to change your database. Is there a way to go out there and spy on your organization? And then we get everything from packet sniffing across your database. But what we found that's relevant and works is you go out to your operational data sources, and you sniff the logs. So whenever you make a change, and some people may be aware of this, maybe let me give it a second thought. When you start changing data in most data sources out there, there's breadcrumbs being dropped. It's going into what's called a transactional log. It's a different set of files physically, separate from your Oracle, your SQL Server, MySQL. They have a transactional log. And then some of them have callable APIs. You can actually call into them, say, hey, what are you up to? What are you doing? You can ask it, what you got that's, it's dirty, what you got that's clean, what has been committed. And you can query that and literally say, do you have any table? I'm looking for table A, B, and C. Is it in there? What have you got? And you can start getting the changes. You can, depending on the underlying data source, they're all a little different. But we actually will start getting the changes, and then we sit and wait. And the minute we see the commit, we package that committed transaction up and put it down the wire. And that's how we approach it. We're not the only ones that do it. Oracle's got something out there that does it. Microsoft has something out there that does it. IBM, they're all out there doing it. But as we go further through here, we want to talk about what can you expect and what's the easiest way to do it. But today, what I'm talking about is log-based change data capture. I am sniffing the database's log, and it's giving me a heads up of what's being changed and done. And that's not the only way to do it. There's triggers to be used. Change your code. Timestamp your database. There's probably 5 different methods of doing it. But as we start exploring the other ones, they become very human resource intensive. It's going to take a lot of people to rewrite your app, re-architect your database. If it's a packaged app, you can't touch it before your warranty, so there's a lot of restrictions in there. And so that's what I talked about earlier. The battle has been won. This is the way we're going to attack it. There's only really 2 non-invasive ways to do it. One's really scary, it's called intercept libraries. And that's basically something between any way of touching data and the OS, and it sniffs it and pops out a log. There's a time and a place to avoid that at all possibility, and sometimes you can't. But the dominant way of getting at most of the changes that occur out there is looking at the logs. And that's how, kind of the relevance of what I'm going to talk about. Any issue question?
Yes, but you may actually have a case where you are looking fast more than you can actually transfer to the warehouse, given the time limit or something like that.
A time window?
Yeah, time limit. So what would you do in that case? Like you may have to get more data log that you can actually transfer from the web log.
So that's possible.
That's possible.
That is possible. So
Then you will be behind, and the more data comes,
it's conceivable. It's conceivable that it's so unprecedented in the amount of data that's being changed that you could now, given the community that I'm talking to today, where you're coming about, first off, there's only a handful of organizations that might fit that way. And I'm not saying I've never seen it in the field. And we've been able to cope somewhere between 240 and 250 gigabytes of changes an hour. That's a lot of data that's changing. Do I think we can go bigger, badder, and faster than that? Yes, I do. And it really depends on the pain point and how much. Remember, it only takes time and money. That's all it takes, time and how much. So if we start looking at this one test that we did, when we got to that level, we can start looking at, well, what kind of data? Let's go in memory. In memory. Put it all in memory. If money's no object, double the size of my Linux server. Quadruple the memory. It's just somewhere along the line that how much do we want to pay and what we want to do with it. Just not that long ago, I was personally sitting there with my R&D team, with my SE in the field, working at one of the world's largest retailers, and they want to get the data. They got data in Denver, and they got data up in Minneapolis, and they wanted to literally, we took the entire, we log shipped all the logs, and we put a generator on there, and we started tapping out somewhere around, in their infrastructure, on that day and that moment, around 240 gigabytes an hour. So there's one.
Changes per hour.
Changes per hour in the logs, yes.
this maybe a silly question. Are you storing replicas of a replica of the database?
I got the traffic, but one year is listening to New York.
Are you storing replicas of this, or it's just one single copy?
In the case of the CDC, and it's a single database, we're going to have a single agent pulling against that new database, and it's transactionalized, so it's one agent. It's a balancing act. Could I attack the log file with multiple agents doing it? What we eventually found when it gets field evidence, we're better off going to do it one time with one agent and just then. Could I have two programs both going with it with a different set of tables, or take all the tables and put them into one program? We have found the long run. That's what we found in real life field evidence we're going through the log, is that don't have lots of programs slamming up against it, because it's like another user against the database. It may not show up, because you're not going to hit the database, you hit the logs. But when in this case of the 240 I was talking about, it was a singular application. Now, there's a lot of logic and a lot of things. If you're willing to loosen up on referential integrity and the purest aspect of the transaction, we can start grouping it. One of the things that change data capture points out, the concept of the log file, is not necessarily particularly flattering to the application developer or the programmer, unless that's the way they wanted to write it. We started working in with some of the organizations that we've been doing business with for about 10 or 15 years. I got one guy on my team who's an absolute guru in this environment. It's the old traditional, it's a basic program. It runs the largest legal company in Canada. And they had a classic green screen. It was actually running on a digital computer, and it was working with a file system on this data. We started doing change data capture on it. So someone would go into a screen, and they would just start going through and changing the data. Lo and behold, a couple of really big bad things started coming out. Every time they moved from field to field, they updated the database. So you had to do what seemed like one simple update. The developer kept writing out from the log-based. That's like 10 records, 15 records. What we started realizing, it's one record, it's a sick, roll it up. Roll it all up, and when we put it to the data warehouse, 10 to 1. So again, that starts addressing the throughput. Start using techniques that you get the volume, and when we put it into the target, it's not as bad as it was when it was created. And so you start looking at the developer saying, 20 times, you update the database 20 times, get one simple update. You just see that, you kind of wonder what the logic is behind it. So that can kind of be, it spells out that. You see those kinds of things happening.
The original developer was in a retirement fund at that time.
I'm afraid it wasn't. They didn't claim it. Right, so, best practices for doing this. So we want to start talking about that. So when we start looking at that, given the environment and the host of what's here, there's many ways to attack this. That's what I said. Either as developers, there's nothing that says that you can't crack. If you had one database and you really knew it, and you're really good with it, whether you can start looking at the logs of the data itself. That's a way to do it. Build it yourself. Absolutely viable. There's many ways of doing it. There's many different tools that are going out there. Some database companies include it. It's free, remember? $5,000 a CPU or $25,000 a CPU, but it's free if you go to step up to this level. So they throw in enterprise class ETL, they throw in all this, they might throw in change data capture or replication for the database. Again, what I'm honing in on is identify what's changing and get into the data warehouse and the data appliance. So what we want to look at, things to consider, real-time fast. I think real-time is critical. We can always do both, but there's many ways of doing that. Simplistic way of doing it. Some of the original ways of getting at doing this were very script-oriented. They're kind of like just evolved a little bit off the classical 3GL mentality of accomplishing it. It was more from a DR perspective. The first kind of methods at a software level of achieving this was more towards DR. Hold God forbid. Get it over there and keep it in sync. Because hardware alternatives were just too much money. Obviously, if we're going to be realistic, we want to have a lot of sources and targets. This goes back to what I said before, the non-intrusiveness, about there's many ways of doing this. How do you want to accomplish it? As a developer, as a DBA, as an analyst, how do you want to approach it, what's your cost structure, how many people do you have to throw at this. And then you want to be aware of what's going on, to know what the latency is, to, if it does fall behind, and you kind of price to that. If it made it, one of the places where have we seen our greatest latency out in the field when we do that is typically nighttime. They still have this batch mentality. They may not be batching the movement of the data, but back to that supersized cable company we were working at, we started finding we'd be coming in the morning at 6 and the latency was up. It wasn't at that 1 or 2 second latency. It was falling behind, so we started finding out when you do a little digging, and this is, it's great time for some of the developers to vacation or something. We found out that they were running nightly batch jobs when they updated every customer record in the database. Why? Because that's how we released it. Did it all change? Oh no, maybe 10%. But you touched every one of them and wrote it back to the disk? Yes. That's what I'm talking about. So what they went out and did in a short window, when they ran on a multi-parallel CPU machine, they touched every record in the organization. Not necessarily a good idea. But depending if you're monitoring or watching it. So those are the things that start coming out. We find the greatest latencies late at night when those ugly little batch programs go kicking off. Nobody knows what they do. They change data capture. They become warts. They stick out like sore thumbs. What in the world would you do at 4 in the morning to get touched 30 million records? A lot of on-demand TV at that time. So, look for easy setup. The idea is, I want to be able to get the, data in a simple process of identifying the source of the target. I want to be able to get the full load job done. I want to get the change data capture done. I want to get it all done, and I want to be able to put it out there and work at it. So, ease of use. We've got to change what we do. We can't keep coding our way to a solution. Again, it's not enough that you put it in place. It needs to be self-aware. It needs to know what's going on. It needs to alert you. It needs to tell you about it. Look at ways of controlling it and working it and doing it. So when we start talking about this, what makes up a successful change data capture implementation? Well, you've got to seek the database in the first place. You've got to get everything that's over there. So you can't take a blind eye towards moving large amounts of data to do that. And we've had the opportunity to work with companies and create high-speed loaders. So let's go load the data up. And now, it sounds simple, but it's got to be it's a somewhat complicated way of loading it if it's going to really be easy for you to do it. So I've identified all the databases and tables that I want, and I say, now go. Well, that could be running anywhere from minutes to hours. And while that's going on, you just can't turn off your organization and say, just don't touch anything for the next 10 hours, or it's back to nights and weekends. So while this is happening, this thing needs to be smart enough to be tracking everything that's going on in city load. And that as each table gets down in there, it then takes off behind the scene and starts applying everything that happened from the time I started the full load and completed it, it might have changed. So make it relevant again. So there's a lot of subtlety. It's, when we just think about this, our mind escapes the fact that there's a lot going on behind the scenes, and we need to be aware of what's going on in the act. And again, this whole idea, if you can, do it on the fly, do it in memory, and if possible, and to one gentleman's question, well, we start kind of blurring the image between if I want to do high-speed replication, CDC, and classical ETL, draw the lines of what we're going to do that. So we recognize that you just can't take data literally exactly as it is, but in the fly, minimizing the complexity of it, can I do transformations on the fly? Can I concatenate, add columns, drop columns, change things, make some relevance in that, and be able to manipulate it as it's flying through the system. And then that's what we're trying to accomplish and do that. We've also recognized that when you think about this, that it's not just the data that's changing, but the database. And then all of a sudden someone drops a table, adds a column, drops a column. Wouldn't it be cool that just literally as part of getting the data over there, I can update the schemas and change that and do that in the fly too. So as you have the EDL change, you kind of see that here as you're going over there. So then we automate the full thing. We start thinking about generations and we're going to work on that. Load all the data. We've got the incremental that's going on, and that my database could be as actively changing as my data itself. So again, hitting on that the non-intrusiveness. This is the idea. Do I want to make it myself, or do I want to explore what's out there and something that can help to do that? So when we start talking about non-intrusive, it's at many different levels. There's that I don't change my app, I don't change my database. That was pretty straight up with what's going on there with log-based CDC. But what then started happening is, but you still need to install something right cozy up to the physical database. And the way IT shops run today, there's you start looking at packaged applications and things that are out there. I can't get on those machines. And with the advent of the client APIs that all databases afford you, it is now possible to achieve everything we talked about and not necessarily install source code target. So you can set up your own independent, standalone replication CDC environment without having to go on the source, without having to go on the target and accomplish this. I think that, it's something to strive for. Then you can throw the horsepower that you want behind it and achieve it, and it really brings your costs down and be able to do that. This is just about, I gotta have, one way of looking at this is many of the vendors have kind of a silo approach to themselves. But at the end, if you're going to be working with large-scale appliances, you're going to need to be able to talk to a lot of sources and a lot of targets when you're going to accomplish this. So I just wanted to bring out some of the things that I've done in the field, that we've done this, and the idea that we worked with incredibly large organizations, small organizations. And the idea is, one that we're finding is that heterogeneous, the idea they've got DB2, they got SQL Server, they got Oracle, they got it all. And they want to get it into the appliance. That they too, what we're starting to find out is just about every major organization is not only getting their warehousing, but they're going to some flavor of an appliance. And there's probably like 5 or 6 of them out there that are relevant. Today I'm going to actually pick one what I think is considered the largest database appliance vendor out there is Terry. And we'll show a little bit about that. We talked about this. I want to go along this. What I want to talk about cloud and kind of share with you my feelings about that is that literally the 800, 1,600 pound gorilla in the cloud community, and most people call out cloud is they are showing the world really literally what's going on there. They are going at an unprecedented rate, and it's really going on there. I know that there are some database backup systems that kind of hold the point to this. I teased and started reading this. This is my own way of thinking about it. If you actually look at who's the #1 company for getting data into the cloud in a very timely basis, most people don't actually figure, they start thinking of infrastructure. It's actually FedEx. Fastest way to get data into the cloud is to slap a high-speed device on whatever thing you're going to do, drop the data on that thing, hand it to the FedEx guy at 5 or 8 o'clock at night, and have him get it there at 8 in the morning, and then put it in. The cost of building a band to move several terabytes of data over the internet or intranet or whatever you're doing is astronomical. You can't beat the FedEx guy. He can get it there faster. So, and don't think that all the cloud providers out there aren't aware of that fact. So when I remember reading an article in the newspaper where this company kind of changed the thing about having individuals back up to the cloud. The way when you buy your solution, the way it works, they literally ship you a little external hard drive and say, put all your data on this first, mail it to us, and then we'll incrementally think at that point. It actually works. So when we started getting out here and working with Amazon, and we did this, and another technology we have, this is more file-centric, and what we've actually been able to put out into the field, and being able to do that, is take everything we talked about before we got up to this, and say, all right, how am I going to get that in the cloud? Well, the cloud is even a harder solution in that it's got to be the deltas. Literally, it's got to be the deltas. You can't bulk load it in there in many cases. You're going to have to find a way of seeding it in there or come up with a method to do that. So traditional bulk load on ETL is very, it uses ODBC. So what we know now is when we know source and target, we've got to change the way to do it. The most efficient way to move data in large distances is identify what you want, put it into a lot of small files, and use kind of a sophisticated compression and file movement technology, think kind of FTP on steroids, and get it up there, and that's the methodology to do that. So we took one technology, replication in CDC, married it with another technology, find a very efficient way, knowing that I have a wide area network and how I'm going to cope with that, and then achieve the ability to actually get it up there into the cloud, just what I want, in a more efficient manner. And I don't know the numbers, Kevin, you were one of the first to get it out there, the organization. Another place where you see it, and remember, the cloud is nothing more than another data center that you may or may not own, it's just someplace you're not. And we have, so whether it's cloud or someone says, I've got a data center in New York, and I've got one out there in Oregon, and I got to move it behind. You face the same, whether it's a private network or they're just VPNing and running it over the public network, you can run into the same systems. All of a sudden, your bandwidth is dramatically dropped. So the solution set, what are we going to do? To move the data and get through the bottleneck. The story starts sounding the same thing. What you do is you still want to change the capture, you still want to load the data. So Redshift, so relational data sources, so that's Amazon Web Services. Actually, if you go out there and say, I want to build out my servers, I'm going to build my whole organization in the cloud, they offer you Oracle, MySQL, SQL Server, those are the RDSs. And then Redshift is Amazon's data appliance. It competes against Teradata, PDW, all of those, except it's hosted up, on their side. And so it's now, think about it, like this huge, highly scalable analytical engine up there, its Achilles heel is even bigger. It's a bigger problem. How do I get it out of my organization? Get it up there. You've got to reinvent the way you're going to do it. The traditional ways of doing it absolutely will fall down. So if everything I said to you doesn't apply to your organization, if you're trying to go remote, whether it's the cloud or a data center, you've got to change the way you do it. It will not work. The network will be so slow that it was an excellent question. You said, can you cope with the changes fast enough to get it over there? You throw a wide area network in there, and this idea of 240 gigs an hour, forget it. That you're dead. The pipe you got from A to B, even if I can get a technology that can extract it out and identify it, the network will never do it. It just simply will fall back. It's incapable. Because this one test case that we talked about, unfortunately, all the data we needed was sitting in Denver. So we had to get them to really log ship all the data. We waited for them to get it over the network because in the real world, everything was going to be in one data center, all on one, 10 gigabyte network. And then the pipe no longer becomes the obstacle. It's the technology that around it. But the cloud, it is the pipe. So then we start looking about everything we got going on there and how we want to load into, literally, basically. It's literally what we're talking about. So by marrying two really cool companies come together and take the idea of CDC and all that, and someone who created a better way of moving data around the internet and managing file transfers and marrying the two technologies, and that's the result of what we've been able to come up to and achieve, from a cloud perspective, so we can get that cloud solution. Again, the idea and the two things that are going on here is literally the complexity of doing it, what they thought they were faced with, not being able to have a tool, they thought they were going to have to script and code everything we're going to do and figure out then also how to transfer. But that they can literally sit down in an environment where all that becomes transparent and so achieve the thing. So it's a combination of saving a lot of time and being able to work with their source inside the data center. They had SQL Server. They wanted to get everything into Redshift. Common theme. Save a lot of money. Again, difference between these two is these guys save more money and they haven't had to work. All right.
You're going to show it now?
I have it down. I'll take a break, let people do whatever they want. If they want to see one possibility of this, at this point, we're going to do straight up questions and all that. And then we're going to do a live demo for anyone who wants to hang and see all of that.
It's a short demo.
And it'll be a short demo.
Before we move on, I just want to give a great big round of applause to Richard Thomas, Director of Technical Services. And we have a surprise raffle down That was unexpected. We're giving away Attunity is giving away a $100 Amex gift card to someone in this audience tonight. All you have to do to enter is drop your card in the bucket. You gentlemen over there, can you look straight down to your left? Your left, look straight down. There's a bucket there. Do you mind just passing that around?
If you don't
If
have,
you don't have a business card, you can write your information straight down on any piece of paper or back of a beer can or whatever you want.
or actually, John, business cards you could use to write on the back of it.